Hello, everyone, and thank you for attending my presentation, 5G and Edge Network Clouds, Industry Progress and the Shape of the New Markets. My name is Görkem Yiğit. I'm a principal analyst in Analysys Mason, and I'm responsible for cloud infrastructure strategies and edge and media platforms research programs. Today, I'm going to talk about our recent research on cloud-native 5G networks and the edge computing. So I structured this webinar in three main parts. First of all, we are going to look at the state of the market, wherein the 5G networks and the cloud-native transformation is happening, and what is the pace of it across different 5G domains, and also what is the impact of this transformation on the vendors and how it is reshaping the value chain. In the second part, I'm going to focus more on edge computing and talk about where the revenue opportunities are for telecom operators. In the final section, I'll discuss the evolution of from cloud native to edge native as the highly distributed edge native applications will emerge in the 5G locations. Okay, so I'd like to start with what we really mean by cloud native from telecom operators' point of view, and what is the relationship between 5G and the cloud native software. Operators have been on a long journey to make their networks more software-driven and cloud-based since the inception of the NFV idea. The cloud native is the new phase of this journey with a much broader scope and a much more significant impact on the way that the networks are procured, built, and operated. As the CNCF defines it, cloud-native networks are microservices-based, decomposed network functions running on containers and the Kubernetes ecosystem. But in the telecoms world, it takes more than just the CNCF definition to become cloud native. Operators need highly resilient, scalable, and observable networks and operations, which are underpinned by capabilities such as open and declarative APIs, multi-cloud portability, service meshes, immutable infrastructure, and live updatability. All these features and capabilities together define a true cloud native network that is needed to build the right cloud platforms for the 5G. My colleagues in Analysys Mason Consulting, they recently modeled the potential impact of 5G on global GDP, and they estimate that the 5G could potentially add $300 billion cumulatively over the next 10 years. And the affinity between 5G and the cloud-native software is very important to realize this potential, because the cloud-native network platforms and skills will play a critical role in creating the new 5G, edge, and advanced connectivity services that will generate this value. If you look at it, 5G is the first operator network that can run on the cloud and built using the same foundations and building blocks of the cloud-native IT applications. This means that the 5G network microservices can be created and managed just like applications, and operators can build a common digital platform for any software, be it the 5G core and the RAN network functions, or enterprise edge and IoT services, or even the operational software supporting the management of these networks and services. So this convergence of the software-driven, programmable 5G cloud-native infrastructure and applications will be the key to unlocking the new monetization opportunities in different industry vertical services and ecosystems. So what is the state of cloud-native transformation today, and where do the industry expect to be in the next 3 years? We recently completed our Cloud Transformation Benchmark, CTB, which is a unique research that measures the level of cloud-native readiness of telecom operators with regard to network functions, deployments, and operations. And as I mentioned before, the cloud-native transformation and 5G are closely linked to each other. So this study also provides a measure of operator 5G readiness. Over the last 6 months, we conducted in-depth interviews with 10 operators around the world, as you can see on the left, with the assistance of Linux Foundation. We talked to the senior management and executives that are in charge of their organization's cloud-native transformation, and we asked them around 40 questions about their cloud-native technology strategy and activities, adoption timelines, as well as the questions about their organizational and cultural change. Based on these inputs, we developed a benchmark model where operators are positioned in a matrix that measures their technology and organizational maturity, which we'll see in the next slide. So this is our main results matrix for the first phase of this study with 10 participating operators. and we keep their names anonymous unless they want to go public. So we measured operator inputs mainly in two areas. The y-axis, technology maturity, which marks operators' cloud-native vision, implementation progress and roadmaps, and the level of cloud-native automation and agility they have achieved so far. The x-axis is organizational maturity, which analyzes to what extent operators are prioritizing the cloud-native transformation and the level of support and investments they have from the other business lines to drive the organizational change. CTV operators currently fall into 4 groups, and we have the most advanced operators in the cloud-native visionaries and primed adopters groups. And as you can see on the slide, all 3 North American operators are in this group, along with an operator from developed Asia Pacific. European operators are clustered around the cautious adopters and followers group, which have made less progress on both axes than their peers in North America and the developed APAC. As our metrics shows, no operator is truly cloud-native today. However, the cloud-native visionaries that are making strides towards building their cloud-native 5G networks and preparing their organizations. So in other words, they already started the race and they're heavily influencing the industry vision of cloud-native 5G today. Their next step is building and operationalizing the cloud-native networks at scale. We call the primed adopters primed because they're on the starting line, but they haven't started the race yet. They have a quite balanced approach to cloud-native transformation. They set a vision and are experimenting with cloud-native software. And in parallel, they are putting the necessary investment in organizational change and acquiring the cloud-native skills and software mastery. When we look at the European operators in the cautious adopters group, we see that they've made some progress in organizational maturity as they're further along the x-axis than the followers, but their overall technology maturity is still low. This is because these operators started their cloudification journey with NFV years ago, and operational and organizational investments they made in the NFV era prepared them for the cloud native to a certain degree. However, because the cloud native technology and the Kubernetes ecosystem is a radical change, their previous technology progress isn't as equally transferable to the cloud native. And we call these operators cautious adopters because they are skeptical about the technology and they believe that the vendor solutions aren't mature enough to make large investments yet, so they're not investing in it at the same scale as the visionaries or the primed adopters. And as always, there are operators in the followers group who are still exploring and understanding the technology and its implications, and they are still yet to make significant decisions and moves before having more clarity. In fact, we believe that most of the operators out there would be in the followers group if we were to include them in this benchmark, because these 10 participants are among the largest and most technically advanced operators today. So let's have a look at CTV operators' cloud-native implementation timelines and what will the 5G network look like in 3 years' time. On the left, we have the roadmap for different 5G domains. And as you can see, 5G standalone core is the most ripe domain for cloud-native deployments. Many of the operators started deploying their cloud-native 5G SA core today, and most of them are expecting to get to the commercial deployment within 2 years. Some vendors made significant progress in architecting their SA core solutions for cloud-native, especially the software-centric new entrants who started building these functions from scratch. So the SA core is the main target for cloud-native today. When we look at other functions, however, the story is a little bit different. There's a big focus on the cloudification of the radio access network today, but the vendor solutions are lagging behind SA core in terms of cloud nativeness. Cloud native visionaries are pioneering the vRAN deployments today, but for the majority of the operators, the adoption of the cloud native vRAN is at least 3 years away. Cloud native IMS, on the other hand, is somewhere between SA core and vRAN, but our conversations with the vendors reveal that the cloud native IMS products are not being developed at the same pace as the core and the RAN because it's not a top priority for operators in general. On the right-hand side, we show operators' expectations on how the 5G network will look like in 3 years' time based on these adoption timelines and the pace. Most of the operators will have a hybrid 5G network with a balanced mix of traditional physical, NFV, and cloud-native functions. So for them, this is pretty much an evolution of the network. By contrast, the cloud-native visionaries are aiming to move everything that can be cloudified to a cloud-native infrastructure by 2024. So for these operators, it's really about changing the network paradigm and disrupting the industry as quickly as possible, rather than a slow evolution of the network we see from the other groups of operators. So when we combine these insights from the CTB study and our broader cloud and 5G research, we see that what do we see in terms of the vendor opportunities, and what does this trend towards more open and disaggregated cloud-native networks mean to the value chain? We forecast that the total mobile network cloud infrastructure spending will surpass $27 billion globally by 2026. And we broke that spending down into the key market segments, as you can see in the slide. There are two key points I'd like to make here. Firstly, in the NFV phase, network equipment providers, NEPs, they continue to control the lion's share of this market because NFV didn't really bring openness, and many operators use pre-integrated stacks from NEPs in their NFV networks. However, cloud native could be the harbinger of more open and disaggregated way of building telecom networks. And this is because the cloud native design principles inherently make the horizontal and disaggregated network cloud deployment models more feasible. This means that there are many more players competing for a share of the same revenue pots, as we highlighted here, and these new entrants and the challengers have a much better opportunity than ever before. Of course, in the telecom industry, nothing really changes very fast, and single vendor stacks will continue to be a main deployment model for a long time. But the bottom line here is that the 5G and the cloud native is laying the foundation for disaggregation and gradually forcing the market to change. The second point I want to make here is about the opportunity for the public cloud providers. We are seeing that the shift to cloud native architecture is driving the use of public cloud providers, or PCPs, cloud platforms, because operators hope to get superior cloud technology for their 5G networks with fewer hurdles. Based on our primary research with operators, we assess the level of interest in this model, and we estimate that the PCPs can potentially capture as much as 20% of the 5G mobile network cloud stack by 2026. 5G SA Core, and to a lesser extent, the vRAN are the primary candidates for this shift, and this will be in the form of PCPs on-premises cloud stacks or in a hybrid architecture. I should note here that it is still too early to tell how much success PCPs can really have, because the initial experiences the pioneer operators have with PCP cloud stacks, and whether these stacks will be able to fully meet the expectations and hit the milestones, will determine how much public cloud providers will be able to disrupt the market. So I want to shift gears here a little bit to edge computing, as 5G, cloud native, and edge are strongly interconnected. Over the last few years, we assessed the demand for edge computing services from hundreds of large enterprises across different verticals. And we asked them how much of their IT budgets will be allocated to public edge services. And by public edge, we mean the edge computing offered as a service from a third-party location. And from a telco perspective, these would be the edge clouds that are in operators' metro data centers, central offices, and cell sites. So our primary research with enterprises indicate that the public edge computing market spending could reach $34 billion in 2025 and $70 billion in 2030. There's no killer use case for edge, but it will be a variety of use cases and applications from different verticals. Manufacturing being the largest, and followed by financial services, healthcare, and media and entertainment sectors. Of course, these figures include the services from all types of edge service providers, not just telecom operators, because the edge value chain is highly fragmented with a diverse set of players. And telecom operators' role today is mainly limited to providing the physical locations for edge clouds. However, in the future, the bigger opportunity for operators will come from the next generation of applications, which will require a more distributed edge compute fabric, which is available not just in a few locations, but thousands of distributed edge locations globally. These applications include computer vision, natural language processing, blockchain, automated guided vehicles, and the much wanted metaverse. We call this category of highly distributed applications edge native, because they are being developed using a very different architectural approach from today's web applications that run in the public cloud. But the bottom line here is that these applications will require far edge locations, such as vRAN clouds, that require a similar level of security, latency, and the compliance, same as the RAM functions. And the mobile operators that build these far edge clouds will have the opportunity to move up the edge value chain. These far edge services would enable operators to capture a larger share of the public edge markets, which we estimated to be around $24 billion by 2030, as shown in this slide. So how does edge native applications differ from cloud native in terms of their infrastructure requirements? Today, edge is pretty much a scaled down version of public clouds. However, the next wave of edge native applications will need a different cloud infrastructure, orchestration, and a service layer. So if you look at it, the IT workloads today run on public clouds, which are very large centralized data centers with near unlimited scalability and a vast amount of servers. Whereas the edge native applications will run on distributed computing platforms with a large variety of locations, and some of them will have physical constraints such as power and space. And speaking of location, in public clouds, location was pretty much irrelevant, as cloud inherently means that apps can be deployed and moved anywhere. Of course, there are some exceptions, such as the data sovereignty issues, but location wasn't of critical importance. However, edge native infrastructure has to be location aware. The resource availability for specific use cases, as well as latency and security requirements, are pretty much location dependent. And as such, we can't expect the orchestration and the Kubernetes to horizontally scale from one edge cloud to other without factoring in the location parameters. A key distinction will be that the edge will be a highly heterogeneous environment, unlike public clouds. Several edge use cases require specific hardware resources, such as GPUs, FPGAs, or any other XPUs, or in some cases, low power chipset architectures such as ARM. Also, networking and storage configurations will be use case specific as well. So edge native infrastructure will need to be capable of automated management and programmability of this heterogeneous environment. Another key characteristics of edge native infra is the ability to support devices that may not always be connected, such as the vehicles moving from one tower to another, or the remote assets in rural areas, such as oil rigs or wind farms. So the applications and the infrastructure need to build with that in mind. Today, in the cloud native worlds, it's assumed that everything is always connected. So all these different requirements of edge native will have implications on the orchestration, the workload placement, and the scheduling in edge native. So it will require more advanced orchestration capabilities than what Kubernetes provide natively. All these different requirements and capabilities of edge native mean that the operators, as they cloudify their networks, particularly the 5G RAN, they should consider laying the foundations for their edge native strategy and adapt their infrastructure and orchestration for the next wave of edge native applications. So I'd like to wrap up quickly this presentation with some conclusions and recommendations. First of all, cloud and automation is driving a massive change in every industry. It's not just in telecoms, and 5G has the potential to take a big role in this change. To realize this potential of 5G and even beyond 5G, operators need software-driven cloud-native infrastructures that can be manipulated and programmed just like IT applications. This transformation is essential to be able to participate in the value chains of the new vertical services and compete with other players that were born in the cloud. And this is not just about the technology. The organizational change, including the software mastery and the right mindset and the culture, are critical parts of this process. Secondly, as I said earlier, 5G is the first telecom network that can be built on the cloud, and it is opening the door for new players because the cloud native is inherently open and disaggregated. So it will be important for the incumbent vendors to be ready for these changes and adapt their business models and value chain roles instead of resisting them. The new entrants and the challengers, on the other hand, should set more realistic expectations as to how much they can really disrupt the market rather than being too optimistic. And they should focus on building strong, pre-integrated ecosystems with other specialized players in order to minimize the cost and complexity of openness and the disaggregation. And finally, 5G RAN clouds are critical for operators' role in the edge value chain, as the new edge-native applications will drive more distributed architectures and demand new 5G cloud locations. This is a significant opportunity for operators and also their vendors to take advantage of. Edge native is still relatively uncharted waters, and they can try to take charge of it in order to influence the way the edge apps and the infrastructure will be designed, built, and operated in the upcoming years. Thank you very much for attending this presentation, and please feel free to get in touch if you have any questions or would like to discuss anything I presented today in more detail.